Welcome everyone. This is BirdSense AI platform. It's an integrated platform that combines computer vision, geospatial analysis, and machine learning for monitoring Louisiana's coastal bird habitats and quantifying environmental changes. Today, I'll walk you through three core features of our system, starting off with Habitat Time Machine, which is this. This is the single image viewer. I'm just going to upload an image. It's a random image that I have of an island. Now, what is basically going to happen is we're going to use K-means segmentation and random forest to segment the image into different topography. The topography is represented based on different colors, green being for like dark green being for dense vegetation, light green for like sparse vegetation, and blue for water, like that. So as you can see, we have on the left side the original image, right side the segmented overlay. We have different metrics that we can view, like water encroachment, vegetation coverage, land area. We have a table and also a pie chart to see different composition of dry land, sparse vegetation, and everything. So let's move on to the second section, which is batch results viewer. All these information are captured from the images that were provided to us with like sectioned Britain Island. We've used Britain Island as a sample. We've used 2010 and 2023 images of Britain Island as a sample. Right now, we're just loading those images individually to see if they're like accurately being segmented or not. So let's see. As you see, we're able to accurately segment the image into land and green vegetation and everything. Now we're switching into different years to see if the metrics get changes. The metrics itself is water water fraction, vegetation fraction, land fraction, dry land fraction. These all information are calculated based on the images that were provided. We used random forest. We segmented the land, and based on that, we've calculated all these metrics. As you were able to see, the image metrics got changed, so that justifies it. So let's move on to the Habitat Time Machine summary. This is the summary of Breton Island in 2010 and 2023. We could see water coverage by year, vegetation coverage, land erosion, and each and every metric represented in the form of bar graph. Now let's move on to the geospatial map. This is the avian colony live map. So you're able to see the map of birds and different species. You can even mark it as show density heat map. So this would basically turn on the heat map based on the density of different birds that live in different sections. If we scroll down, we're able to see the same species based on different compositions. You'd be able to see different species, and if we go if we scroll down, you'd be able to see trend. This trend is based on we have like three sections: overall, single colony, and top trend. And then if we change the metric, we're able to see scatter plot for birds, nests, and everything. So if I scroll down and come to this slider, you'd be able to see the different species and how much they got increased or decreased in different time zones. And if you increase or decrease the slider, the table information gets changed accordingly. And this is what you're able to see. You can even download the filtered data that you've gained based on adjusting the sliders. Now let's move to the top and let's zoom in into the picture itself, the map itself. If you zoom in into the map and click to a data point, maybe this one, you'd be able to see the species of bird that is over there, the colony, Bayo Plate, and year, birds, nest, and all those information that you need. If you click on download map, you'd be able to download the HTML of the map, and you could like host it anywhere in the website.
This is one of the hundreds of thousands of images that Louisiana Agency have captured around the coastal area. But the problem here is 96% of these images have never been analyzed. The reason is very simple. It takes around 20 minutes per image for a biologist to do the annotation, and for hundreds of thousands of images, it takes a lot of time. So, to resolve this problem, we built something called Autodotter, which is a data restruction engine which uses computer vision to mathematically align the screenshots with high resolutionary imagery, and this is being optimized by the segment anything model by Facebook. And we also create training levels, and based like this, and based on these training levels, we train our yellow v8 architecture, which creates a model. And we do have a Python script which uses this yellow v8 architecture to unlock 96% of the on-scene archive. So the script is validate.py, and it precisely counts the bird and also shows the visual annotation for immediate analysis. And take in mind that all these images are never seen by AI. We did 80-20 split to separate these images only for validation. And if I go here inside drones, predict 12, over here, let's see, it does counts the bird and also classifies it based on the classes we have provided. So the red color was used for annotation, so it shows the red here.
Yeah, he's great.
But it also can make mistake. For instance, over here it hasn't annotated the birds, and here there is false positive. So to resolve this problem, we built something called the citizen feedback app, which allows us or the citizen scientists to validate the image and also add a missed birds using the gamification. So my current rank is right now novice scout with 0 contribution and 0 saved, and I can manually verify this. For instance, right now over here it says class redbird, so I'll click on correct. Similarly, redbird, and that's all based on the screenshots we have over here. These are all grades. So I'll do the annotation for all of the 56 of this. I have annotated 56 of this, and as you can see here, my rank is bird guardian now, and contribution is 520 points. So and if you can see here, the validated one are marked with green border, while the false positive are with the blue border. And I need to add these images, and also this is being saved as an image to refine the txt, which we can use to again train our model for active learning. And if I go here and go for image 2, load for annotation, I need to add these birds. So these are being annotated by purple color, so I would go choose the bird purple and click over here, again click over there. And now if I click save new birds, these are also being attached on the same file. And again, for active learning we can use this.